So welcome to the webinar, The Cost of Kubernetes. My name is Van Schubert. I work for Giant Swarm. I work with strategic accounts here at Giant Swarm and work on strategies and plans on how companies can transition or switch to a Kubernetes setup that allows them to focus on their digital products and developing their digital products. And one main reason for actually moving to cloud native naturally is that companies are seeking for more agile ways of delivering their digital products, and that actually has been gradually increasing over the last couple of years. Now, with the events of the last couple of weeks, that has changed quite dramatically. So we are actually facing companies, and this is very interesting for me to see because we actually are a remote first company, so we are working from home anyways. But most companies now have adopted home office as a standard. That naturally affects sales in laptops, webcams, VPN devices, or even online meetings, forcing Microsoft Teams and other providers to go down. So that's something that we actually haven't expected to change that rapidly. Shops are closed, so they actually need to think about how to do online business and to shift their business completely to online. Kids are at home, so homeschooling and education platforms are now soaring. Sports tools to keep them physically and mentally healthy, and actually streaming devices and the social isolation has really driven an uptake in streaming and online shopping, as well as home sports offerings. So the world is changing very, very rapidly now, and that actually forces companies to think very differently about what they should do now, what their priorities are, and what the world actually will look like after the corona crisis actually is over. So that actually is something that we already see picking up, and that's where cloud native can drastically help. So if we actually look at how companies are attacking the change, we typically see one of these 4 use cases or several of them within the company. One is that they are naturally building out the digital sales channels, so the online shops. If we look at Adidas, for example, all shops are closed, so they are basically now shifting all focus on online business because there is no other possibility for them to sell their traditional products. Then we actually have companies like Vodafone that basically have invested in chatbots and technologies that help them scale and deliver services more efficiently, which is something that naturally is peaking right now with a greater demand for bandwidth and other services from these companies. Then we naturally still have the traditional companies that have a traditional product, like Weiland, for example, that produce heating systems, but they're now building out digital products on top of these and services on top of these that allow partners to engage very differently with their customers, like predictive maintenance, for example, understanding how they can optimize their heating systems, home security, home or IoT devices that you consumer IoT devices that make your home or turn your home into a smart home. Things like that, where companies are experiencing greater interest from their customers, and also companies that completely transform their business. They actually have come up with a digital or a product that actually is very different to their traditional product, and they are now looking of ways how to approach the market in a digital or very digitally, interacting with consumers directly. A great example for that, I think, is PMI, so Philip Morris, that actually have been selling cigarettes for the last couple of 100 years, and then basically now came up with ICOS, a very innovative product that is basically a replacement. And so far they have been selling through digital, or through traditional channels, through retailers, and now they need to think about how they can transition their IT environment to support consumers directly, generating demand for consumers with consumers directly. So moving from a push market into a pull market. And one of these approaches is something we actually find typically in all our customers that are thinking of new ways to either bring out new products, increase their revenue streams, change their go-to-market strategy, or even become more efficient by delivering their services in a very digital, scalable way. And to support that, the high change rate or innovation rate these companies face and want to bring to the market, they actually turn to cloud native. And cloud native, naturally, as you all aware, allow you to bring out new products very, very rapidly, allow you to then not only bring these products out, but also adapt them in a very agile fashion. So understanding what the consumers, how they use it, what preferences they have, what needs they have, what works, what doesn't work. So really changing and adapting very rapidly to these needs. And then suddenly in times like these, where you then need to scale, where you need to shift your focus, you can use the flexibility of the cloud to provide the services on different platforms using multi-cloud strategies, either on-premise with public cloud providers or hyperscalers, improve resilience for high demands and peaks at certain times, and naturally help your development teams to focus on delivering their digital products instead of having to worry about infrastructure and other aspects. And when I actually look at a report from IDC, basically they have done some research with companies that have transitioned to cloud native, and they have found that they are generating in average about $34 million more revenue a year through moving to cloud native compared to when they actually would have stayed on the traditional approach. So we've got this opportunity of 34 million in average. I assume that it actually will even be a lot bigger. That was conducted before the Corona outbreak. So this is something that probably will even be a lot higher. And that's something we just need to be aware of. So if we look at cloud native and let's say a return on investment or a cost analysis, you basically need to typically balance out your investment with the benefits you gain. The interesting thing about cloud native actually is that, and that's why I put in the title, two sides of the cost perspective, because you actually typically need to balance out your investment with the return you expect. In this case, it's a bit different because you actually have this opportunity of the 34 million. If you take about 15% as a profit margin, that returns about a profit of 5 million a year. So if you actually don't go cloud native, that's something that you actually will have as an opportunity cost. If you go cloud native, then you naturally have to invest in technology, installation, training, the evolution of the environment, automation, configuration, and so on and so forth. So many, many different activities that I actually will be focusing on in this presentation. And then on the other side, if you actually look at the opportunity out there with the increased profit, then you actually need to see how you can not only balance, but how you can move very quickly in both areas, where if you if you actually invest rapidly in building up these capabilities rapidly, you actually have the opportunity of capitalizing on the profit opportunity. If you don't, then you're missing out on that opportunity cost, and at the same time you're still building up cost for the transition to cloud native, which basically only replaces the traditional way of software development. So yeah, we actually over time we actually don't expect a large increase of IT spend for cloud native versus traditional approaches, but it allows and supports and accelerates your business transformation, and that's something that yeah, that actually allows you then to profit from this area. So the core concept, and especially if you're talking to business stakeholders, this is something that's quite relevant. It's not only about cost, but it's also the time in which you invest that actually plays an important role, because you are already producing opportunity cost right now if you aren't already cloud native in the elementary areas where you're trying to generate business for your company. And that's a quite interesting aspect that I recommend highlighting. So if we then look at the cost of Kubernetes, and let's double down on Kubernetes and leave the other aspects of cloud native, like rebuilding your application landscape and other things out of scope, then you typically have the choice between the two focus areas that you need to really spend time on. One is naturally the technology, that you need software, you need to build up that software, need to upgrade, and so on and so forth. So the traditional aspects of the licensing area, an area that typically doesn't get covered very well is the operations aspect, because companies typically address that in a very traditional way. But I actually would like to highlight both areas in this presentation, where we quickly walk through the technology, but also spend time on the operations side to understand fully what you actually would need to consider when you go Kubernetes, when you already have started on your Kubernetes journey, which the majority of the attendees already have, what actually is the best setup and how to improve the efficiency and the ability to execute on cloud native promises with a setup that is more likely to return the value that you would expect from a cloud native journey. If we look at the technology area, naturally Kubernetes itself and the surrounding projects are open source, all within the Cloud Native Computing Foundation, CNCF, and there are about 250 projects in there. One of the key benefits of open source and the whole open source movement is that there are many contributors from many different companies, and the idea really is also from the CNCF is to provide the flexibility for you to then move your workloads freely between different cloud setups. So let's say you actually you started off on premise, or you started off on AWS or Azure or Google Cloud, that you actually then can decide to move your workloads freely to, let's say, a very quickly evolving market where you have different opportunities. The more you scale, the more efficient an on-premise solution might become. There are some trends towards cloud. Other companies are then focusing on building up their own capabilities again in-house. So that battle isn't decided yet, and we actually also have many companies that will not dedicate and move all their workloads to a single cloud provider. They actually will have different strategies depending on their use cases to then deploy their workloads to different cloud setups, and that's just something you need to consider. Upgrades and security fixes are typically also provided to the community, but you might actually want to support special use cases, special adaptations of the open source version. So you need to think about your support agreements and other aspects to really access these upgrades and security fixes really rapidly, to make sure that you don't hold your development teams back. And automation, the more you scale into cloud native, the more automation becomes an important aspect, which you can then either automate through scripts, or you build operators to actually then have a better and firmer grip on governance and enforcement of certain aspects. So that's what we cover in the technology aspect. On the operations side, we will then talk about fully managing the cloud native stack 24/7, making sure that the developers that are coming out with digital products can fully rely on the cloud native stack to run their applications, and how they can then basically ensure that all activities, if it's upgrades or issues that appear, even their applications may cause different workloads to crash, that everything is handled in a very smooth and productive fashion. It's a very quickly evolving ecosystem, so you need to expect to invest time in constant learning, not only through experience, but also in evolving your landscape, making sure that you actually have the time and the resources to really understand what's happening. Also understand the implications for your platform, but also for your applications, and then there are many different small services, so you actually really need to understand how you can monitor these and understand where you need to focus your activities, and how you can best help the development teams achieve their goals by educating them on what best practices are for your cloud native environments, and what your platform may need to evolve to support special use cases. Security is always an important aspect, especially with cloud native, because the traditional security concepts, where everything stays more static and goes through approval cycles, is something that actually doesn't work at all with cloud native. So that's where your security concept should adapt to understand how anything that you use in cloud native and all the benefit of many deployments really support a very highly secure, multi-tiered approach to ensuring that everything stays up and running, that you actually don't have any security issues with your applications, and that your workloads don't get affected by security threats that typically show up when you have got a very successful service. And another aspect of operations is that you don't keep everything running and just trust on the auto healing capabilities of Kubernetes, but really understand where issues are coming from and make sure that they don't happen again. So you don't have to then spend a lot of time manual work later on, making sure that everything stays up and running, but you actually have you improve the setup and can deploy these fixes to all setups that you run within your company. So here are the basic requirements for this for cloud native that we typically see. If you've got any others, be interesting to see and to hear about that. So if you've got questions, or if you've got comments, then just drop them in the comment box or in the chat box. I'd love to hear about them. If you then approach Kubernetes, there are basically 4 different approaches that have evolved. One naturally is that you do everything yourself. So you actually can go on to the different repositories of Kubernetes and all the related technologies and pull down the latest versions and install it and set everything up. And typically it's pretty straightforward, especially if you've got a development environment and you're just trying out different things. It actually isn't too challenging. But then, basically you need to understand that once you actually go to production, then all the activities are related to this platform needs to be handled internally. So you need to build up a significant internal team to handle that setup. The benefit clearly is that you can customize it to your setup as much as possible. You might have special use cases that might best be covered by an individual solution. But then there are other alternatives out there, like from public cloud providers, if it's EKS, AKS, GKE, whatever, that you then basically can very quickly spin up Kubernetes environments and get your development teams running. Here it's just you need to make sure that you still need to manage that environment. Yes, it's called manage because the public cloud providers typically run it for you and they provide you with upgrades, but then still you need to do these upgrades. If you run into issues, then you need to understand how you can do root cause analysis. You need to understand the setups, and then you either need to choose if you want to further extend your Kubernetes setup with the public cloud providers by open source software, or if you want to take one of the proprietary solutions, be it CloudWatch or other things for monitoring, that then basically tie you stronger into the ecosystem. And that's a very important decision, especially if you're thinking about multi-cloud setups. Then that might impact your cost and your support structure quite significantly. Another option is to go with more the generic container management platforms, where you then typically get a support for multiple cloud platforms. So it's basically the open source technology adapted to certain use cases, to certain setups. More flexible than the public cloud providers in many ways. Here again, you still need to understand the technology that you are then licensing. You need to run it. You need to do the monitoring, setups, issue isolation, and so on and so forth. So there are plenty of activities that you need an internal team to then manage that container environment. And finally, you can actually go to a fully managed service where someone takes over that activity for you, manages it, so you can focus on your pure digital product and really focus on what sets you apart from your competition. In all cases, you will need internal teams. It's just the question what time they require to spend on a technology that is commodity. So if you actually are thinking about moving to cloud native very rapidly, you might want to allocate the resources that you have in empowering the development teams to be able to do that transition and then really bring out products a lot faster, make them more reliable and more scalable, and so forth, and so on and so forth. If you have unlimited internal capabilities and skills, that probably is less of an issue. If you are limited, as many companies are, because the market is growing too rapidly for talent to build up, then you might want to think about models where you need less time to manage a platform and spend more time on educating and helping the teams to transition to cloud native and build their cloud native applications, provision the environment, do the automation, so they can spend more time on innovation rather than having to work and adjust to a certain setup that you might have provided that is most efficient from an infrastructure perspective. So looking at these different aspects, probably something else I might just add, which is another poll, quickly asking what approach are you using? And I'll just launch this really quick, get some interaction going here. So the question is, how are you managing your Kubernetes? It's either no management because it's not in production yet, so we are just using your developers. We manage it as a side project to development. Then we have a dedicated platform team, and we have someone managing it for us. So that actually would be interesting to see what the results have been. So we've got nearly 50% already voted. I encourage you to quickly vote, and I'll be closing this down very shortly so we can continue in our stream. Okay, so I'll close the poll for now, and I'll share the results. Currently, no management required, as not in production. We manage it as a side project to development. That's something that typically happens very early in the projects, where developers actually really spend time on this, on managing the platform. We have a dedicated platform team that's typically a setup that we also have with our customers, where basically we take care of the management, but then there's also a platform team that then interacts with the more the development side and helps them automate it. And here 15%, that basically show that they have got someone managing it for them. That's very interesting. So I'll switch back to the presentation. Here we actually have the cost perspectives now. So let's focus on technology first. So what's the cost of open source? You can either use the upstream open source projects, as I already portrayed. That's naturally free of charge, so you can just download and go ahead. You have upstream development and fixing, so there's a huge community going in and fixing things, and also working on tickets to extend the platform. It's a huge community, so we all benefit from that. But you also might need to consider that in companies, it might be required to have support contracts in place for certain aspects, or you might even want them in case you run into any issues. Then you basically have someone that has certain SLAs to respond. You might also need to invest in contributing to the community, which would only be fair if you use open source software to then basically contribute back any fixes you or issues you find, any fixes you create for them, and extensions, and work together with the community to further evolve that. And naturally, you need to consider the resources to run the software and the traffic it consumes. So either it's on-premise or a public cloud provider. That's basically something that you need to consider. For public cloud providers, you typically have a consumption for managed Kubernetes that typically sums up to a couple of €1,000 per month. So you just need to consider that as a basis. Then you naturally get provided the upgrades and fixes, so you don't have to worry if it actually works with the stack that they provide. It should work. Well, taking aside the applications you run on top of that, that's something you still need to consider yourself, and you need to run the upgrades yourself. And if you run into issues, they might help you with logs, but you still need to isolate the issues, figure out what activity or what it causes, and then go and fix it yourself. If you're capable of doing that. You naturally have support included in that with certain SLAs, and you just need to consider the worker consumption and traffic on top of that. which is something that companies are struggling with sometimes, especially if they start off, because it's not too predictable of how much consumption and traffic they use. Yeah, that's something that there are different companies out there that already have made experience, and you can probably easily ask them what they currently pay for their cloud consumption to get an idea. And then there are naturally distributions, where companies take the upstream open source and then either leave the open source and build something around it, or they actually customize it and build it into their own products. And that's where license fees are, either as a SaaS license or you've got consumption fees. Depends on what distribution you decide to go with. You need to are provided with upgrades and fixes, just like with the public cloud providers, that then ensure that everything within that setup works nicely and smoothly. And typically you also have support contracts with that, where you basically have a certain SLA. And depending on whether you already use that from a cloud or with a cloud offering, or on premise, or within your own cloud subscription, then you naturally need to add the resources and traffic that your control plane, so the master, actually will consume, and also the workers. So that's basically going from nearly free to large installations can easily sum up to a couple of million a year that you might need to invest in consumption and license fees. So that's something that you just, it's very difficult to predict, and the models are very complicated. So I actually didn't go into the detail of analyzing cost comparisons, but our customers actually do that. And I can only recommend for you to really to ask within similar companies at a similar path to really get an idea of let's say opportunities to improve your license costs and technology costs. Something you need to consider is additional components, like for monitoring. You might want to invest time and energy in monitoring, setting up certain probes, making sure that you actually get the logs and everything to analyze, or you invest in technology like Instana that actually has a very smart way of identifying, let's say it monitors everything, and it identifies what you need to be looking at. So that's where you can save a lot of time, but naturally that comes with a license cost. Then you might have networking solutions, API platforms like Kong, or security like Aqua, and so on and so forth. So there, once you have the basic setup, you probably will evolve the platform very likely, and then you will or might end up developing more and more and introducing more and more applications on top of that to get to a perfect setup for yourself and to cover certain use cases. Additional considerations that besides just starting off, spinning up a cluster and then believing that that will be it, you actually should consider the cost scaling. So once you actually use it more intensively, once you go into production, you might have different needs, different requirements, different usage, and that's something you need to consider. I would highly recommend thinking 2-3 years in advance to really understand what setup you very likely will be running. If you are very uncertain, you can do a worst and best case scenario, and then understand from the different opportunities what actually works best for you. Typically, let's say if you actually have an easy setup, then that's something that probably will end up costing you quite some energy and time and consumption later on. So that's why I recommend really making a comparison on how you can start off, and but especially what you will end up with in a couple of years that you might need to support, and that you need to allocate cost to and budget to. The other aspect you will need to consider is multi-cloud. If you decide to go multi-cloud, or at least leave yourself the option of switching a cloud provider, you might want to consider that in your understanding, because naturally, public cloud providers, they provide things to start up very easily, which is a wonderful opportunity to really get started. And then there are, let's say, easy to use add-ons that might be proprietary to the cloud providers, which then basically is something you might face, let's say, a couple of months or even years down the line, where you need to understand what it costs you to operate 2 different platforms or 3 different platforms, and what the license cost may be, and the cost implications in general. So there are different aspects you should consider when you think about technology. Automation is an important aspect. The more so initial platforms, if you've got a cluster, 2, 3 clusters, it's actually less than a problem. But once you actually go to a higher number of clusters, you actually will then have to deal with upgrades and security and things individually. That's where automation comes in, and and you might look for technologies that support automation a lot better than across different cloud providers, maybe, than other solutions, especially compared to the upstream open source projects. And then you might have special policies that require you to focus on on certain aspects to cover them properly in your setup, and require you to then to decide on a certain path, and need to consider in your cost expectations, also in terms of cost scaling in a couple of years, how that will impact your cost, and whether the policy is absolutely necessary, or if there are other ways to adjust it. So yeah, I actually would like to provide you more of a cost indication here, but as you can see, it's not very easy. You can actually start off free of charge, and only basically have your developers take care of the upstream setup, or you can actually go with fully managed solutions that tend to be at the higher end, especially in the very beginning, but yeah, that actually basically level out very, very quickly. And that's at least the feedback that I got from different tenders, is that there are indications that license and distribution costs actually will interestingly affect your cost structure in the future, depending on how much you will scale your environment. Well, the very famous thing is naturally the iceberg, which I want to use as a highlight to actually show that the aspect that the things that you see on the surface is typically the technology, but things that you actually don't focus too much on is the operations, especially in the cost perspective. And it's, interestingly enough, this is the aspect that actually has the biggest attribution to cost, especially over time. So that's why I actually would like to spend the last 20 minutes of this presentation more on the operational aspect of Kubernetes, and how to make sure that everything actually stays up and running, and what time you need to allocate to that aspect of Kubernetes, and especially what resources you may need, or you need to acquire from externally. So if you look at operations for, let's say, for Kubernetes, you naturally need to, install Kubernetes, and let's say, many different components on top of that that then form the whole cloud native stack. You need to secure everything, make sure that you've got RBAC, so role-based access and pod security policies set up and enforced from the very beginning, to make sure that that basically the applications, once you actually need to tighten it because of a security incident, you don't go into a costly and time-consuming effort of adapting your applications. The other aspect, naturally, you need to figure out what matches to your security requirements within your organization. And open source software is great for installing and get it started, but yeah, if you actually want to bulletproof it from a security perspective for enterprises in production, then you actually need to think about this very, very intensively. That's why it's a very important aspect, and it actually is a continuous aspect. So it's not a one-time setup. It's something that you need to worry about constantly and include in your life cycle. Then naturally you need to manage it. You need to make sure that you're aware of the upcoming changes, that you train your development teams on how to best deploy technology on top of your cloud native platform, understand the different use cases, and make sure that you are aware of, let's say, the technologies that can improve the efficiency of the development force, coming up with new digital products. You need to monitor it 24/7, typically, at least, where you need to understand, where are my master and tenant clusters? What health are they in? Are they throwing any issues? Are these issues serious? Are they something that that will go away over time? And if they actually, if they cause any disruptance, you naturally need to go in immediately and fix them, or you need to fix them over time, making sure that you actually can establish an availability of the platform and a reliability around the clock. And also make sure that, once you have different clusters and different setups within your company, that the fixes need to be applied everywhere. So if you've got different solutions in different areas of your company, you probably will have a replicated effort of fixing the same issues. And addressing things like CVEs and other things, so security patches that then need to be applied and arranged with the application teams to make sure that the applications are not affected. And then there's a very important aspect is the upgrades. There are many releases coming out for Kubernetes, but also for all the components, and then security fixes that need to be addressed very quickly. So this is an element that you need to focus on a lot, especially in terms of if you've got many clusters in terms of automation and how you can automate them, that you can have rolling upgrades, that you've got replacements, so you don't end up with many different versions of your Kubernetes environment, that you can make sure that whatever you test it on is also the same version that runs on production, and so on and so forth, or will run in production. So you actually have a great reliability of the service, but also a high efficiency in your operations to make sure that you can actually predict the outcome. And I walk through each of these steps within this the next couple of slides to really address some key highlights and also propose what you might be looking at. So if we actually look at the lifecycle, the install phase, I actually call it install, provision, depending on if it's actually for a new team or if it's a basic installation. Also the configuration, adapting it to your environment and evolving over time. So what you need to focus on is the production grade installation, not the initial one. That's quite easy and not very time consuming. But really getting it to production, configuring it to your environment. You might have multi-cluster environments, thinking about the deployment structure, how would you do dev test part environments, or even a fourth or whatever layer, depending on what your release process looks like. Then think about multi-availability zones to really make sure that it's highly reliable. If you run it around the world, you might have different regional centers or clouds that you or availability zones you might use. For example, Adidas uses two different in Americas, one in Europe on cloud, on premise, and in the cloud, and one in China. So there are special, let's say, regional requirements that you might need to consider. So yeah, that's where complexity builds up, and that's what you need to manage then eventually, and you need to find a setup that really works for you around the world for all the production teams, which is something that will evolve over time. You can't set up something from the very beginning because you actually don't know what requirements will turn up, and there are certain things like split networks where you have your core data in the internal network, and then you've got the customer-facing internet-facing activities. So you might need to build a bridge or gateway to ensure safe traffic, and then you need to adapt it to existing infrastructure. So there are lots of activities that you need to consider in installing and evolving the platform. The continuous evolution is something also very important, because if you get new teams on board, you will need to give them an idea of what the setup is, how they need to develop their applications, then have different availability zones, have different use cases that you need to provide applications for, functionalities that play into the role that they might need, be it databases or Kafka or whatever, depending on the different use cases. And then really evaluating the different applications. Let's say you actually need a different API platform, and what options are there out there which works best for your cloud native setup, which can handle the loads, do test installations, load installations, and so on and so forth. So I think in the minimum, we would say that a half a full-time employee is required for the installation and the evolution of the platform. In many cases, it actually can be a lot more. So the more complex your setup gets, the more you will invest. That's why I put the 2 pluses behind it, because take that as a base estimation, but it's very likely you actually will invest, let's say, easily 4 times as many resources in that area to really evolve if you've got a very complex or a larger organization and want to support many different teams. Another aspect is the governance aspect, where you need to and security, where you need to make sure that everything is secure and is enforced. So you actually have certain security requirements that you need to work through. You need to work together with the security team to understand what their requirements are, what they actually want to achieve. We typically go through that process with every customer in the very beginning. It's very time consuming, but it actually helps evolve the security structure within the company to then support an agile mindset. But still make sure that everything is enforced, so through pod security policies, for example, and that the development teams are aware of all the things they need to consider for their projects. Also, security fixes are something that is need to be applied very rapidly. So you need available resources and people to really understand how to apply them and do that really rapidly. That's where, let's say, you might need to get more people let's say, educated on the security aspects than are working on it full time, because in such cases you need to react very quickly and you need to have the resources available to do that. And naturally, there's a constant tightening of the setup that is required. So also the security concept, as I mentioned before, needs to evolve over time. Here we easily allocate a half person or FTE for that for that role. It naturally doesn't have to be an employee, but also external resource. But it actually is very likely a lot higher in the beginning, especially if you go through securities discussions. You can easily spend a whole person on that full time. Which then dies away or dies out a bit over the time. But then for CVEs, for example, you might need the resources that then know what to do, how to secure things. And that's where basically it's important to consider that these are basic setups, and you might need to invest more time, especially if you go beyond 5 clusters. that's where things get interesting. Let's put it that way. The management aspect is where you can spend time in automation, in education and training of the teams. Here, that's basically you need to constantly analyze your setup, make sure that it supports the different teams, adjust it, and plan out for different elements, provision the changes. That's things that you need to consider in your life cycle. You actually then have training to give to the development teams to make sure that they can use the technology as planned, because if not, you actually will face a lot more downtimes and issues in production. So it's a very very tight balance that you need to hold here to make sure that the development teams really use it in a designed way, and you don't end up compensating for for a lack of training on the development side in building up your infrastructure team to support all the different, let's say, implementations of applications that could have been prevented from the very beginning. And naturally, you can automate a lot to make upgrades a lot easier, to detect errors a lot easier, to set up new clusters, provision clusters, to for the CI/CD pipeline to then deploy applications into these clusters and so forth. So here we definitely recommend 1 FTE, which you easily will need for that aspect. But depending on what approach you take, that can easily increase quite dramatically. For monitoring, you need to decide what you want to monitor, or you basically need to engage companies like Instana that then monitor everything, and then the technology helps you then monitor things. But here the important thing is that you need the capability and the setup to automatically monitor things, go in, alert you when there's something wrong. Typically, it's wise to spend at least a quarter FTE on this job, depending on how much software you have for automating monitoring. If you actually don't use that automation, then you very likely will need a lot more people to cover aspects for complex environments. For the fix element, that's something that is actually the greatest variance in this game. You definitely need, SREs to take a look into your environment. Typically, they actually don't have time for automating discovery and automatic improvements of the environment due to the fact that they actually have so much to do in terms of fixing issues. So that's an area where anything between 1 and 10 is some things we actually see within customers. The more people you actually have that can focus on building automation around it for basically discovery, for issue isolation, detection, resolution, root cause analysis, the faster you'll be at fixing things later. But the more you actually use it, then the more issues show up. So there are customers that are easily spending 10 people day in, day out just on fixing issues. We ourselves have about 500 to 600 postmortems a year. That means when there is an issue and we actually identify that it's nothing that can be healed through configuration or anything, then we actually do these postmortem analysis and then fix it and deploy all these fixes to all customers, making sure that we actually don't only face an issue once. That's where we actually have easily 30-40 people working on to make sure that this actually works very, very smoothly, and you can then allocate the right people to the issues very, very quickly. And finally, the upgrades. That's where you basically need to make sure that you replace the nodes, not upgrade, because you basically have you know, different versions out there, and then you need to schedule the upgrades, you need to conduct them, monitor them, fix them if you run into issues, and you need to make sure that you work together with the development teams to you know, to make the applications more resilient to upgrades, basically based on the you know, on the recommendation. If it hurts, make it more often. That's where, you know, we basically do upgrades very, very frequently to make sure that issues that have been resolved in the upgrades don't show up, and also security fixes are implemented very easily and very quickly. The more you expose yourself to upgrades, the easier it is to implement them. And that's just a learning curve. Here you definitely have to spend about a quarter FTE. These are, by the way, not only our estimations, but also from resources I found, and I went talking to customers, so or even companies that don't use our services. So this is something that you know, should be quite reliable. The choices you need to make are very simple. So either it's, you know, you actually have a business opportunity, or it's if it's a nice to have business opportunity, it's something that you might not want to focus on too much. If you've got small custom software, but you know, but high standardized, it's probably something you don't want to invest in. If you've got applications that are not critical, so that can be healed within 9 to 5, then you don't need 24/7. So these are all elements where you need to understand what Kubernetes means for your company. If you're actually really wanting to address the market and have a business opportunity, then you should at least account for FTEs in terms of cost, in addition to the technology cost. And then it actually becomes more relevant to really understand what is the benefit of moving to Kubernetes, either slowly or by building up a team yourself, or if it makes sense to get a external support, like you know, different vendors offer either a complete, fully managed, or at least the technology side with support and fixes, to then embark and reap the benefits of cloud native as quickly as possible. So I'm a bit over the time. Actually, I thought I'll have some time for question and answers. But yeah, actually, I'll just stay on for another bit if you can. Then yeah, you can feel free to ask questions and I get into them. If not, then you know, we'll just reach out in the next couple of days and see if there are any questions that we can help you with. So thank you very much for attending the webinar. And looking forward to seeing you again in the next couple of webinars, which will address, and we'll be inviting several partners to do webinars together with us to then highlight different aspects of the technology stack and solutions out there that might turn out to be very beneficial for your environment. Thank you very much for attending, for signing up. And if you've got any questions, you can ask them now.